Okay, so this is 2025 Higher Level Maths Junior Cert Paper question 7. One section of a golf course shown in the diagram below is in the shape of a rectangle with a semicircle at one end. This shape has a width of 50 meters and a total length of 300 meters as shown. So we have to work out the distances marked x and y on the diagram. X is the radius of the semicircle. Okay, so this is reasonably straightforward, I think. The distance from here to here is 50 meters. So that means the distance is from here to here is 50 meters. Half that distance is x. So x is just equal to 50 divided by 2 if you like. So just 25 meters. Now y is this distance here. Well, the distance from here to here is 300. The distance from here to here is y. And remember, we just worked out x here is 25. So the distance from here to here is also a radius. That's also 25 meters. So all we've got to do is subtract 25 meters from 300. That'll give us y. So y is equal to 300 minus 25, which is 275 meters. Okay, so let's move on to the next question then. Hence, work out the total area of this section of the golf course. Give your answer correct to the nearest square meter. So you got to work out the area of this green part here. So the green part is made up of this rectangle and this semicircle. So the area of a rectangle is just length times width. We have the width now. The area of a semicircle is half the area of a circle, so it's half pi r squared. So we have all those numbers, so we can just put them into those formula. So let's see, the area then is equal to the length times the width, so that's 275 meters times 50 meters, and then the area of the semicircle is half pi r squared, so it's half times pi times the radius, which was 25, which we've got to square. So you can do all that on your calculator. You get 14731.7477, and that's square meters. We have to give our answer correct to the nearest meter squared. So what we're going to do is stop here. So the number after the 1 there is a 5, 6, 7, 8, or 9. So that means we got to round that 1 up to a 2. So it's 14732 meters squared. Okay, next one then. Macage is spreading fertilizer on the whole golf course. The packet of fertilizer has these instructions. Use 6 liters of fertilizer per 250 square meters of ground to be covered. Macage needs to cover 809,371 square meters with fertilizer. How many liters of fertilizer will Macage need to use? Give your answer correct to the nearest whole number. So first thing we've got to do here is take the 809,371, which is the total area that needs to be covered with fertilizer. See how many 250s divide into that, because for each 250 square meters of ground he needs to use 6 liters. So we've got to see how many 250 square meters there are. So when you do that, you get 3237.484. So we have this many 250 square meters in the area we need to cover with fertilizer. So each of those requires 6 liters of fertilizer. So what we do is we take 3237.484 and we multiply that by 6. That'll give us the total number of liters required to cover the course that he wants to cover. So when you do that, you get 19424.904 liters. We have to correct to the nearest whole number, so we've got to stop here. So the number after the 4 is a 5, 6, 7, 8, or 9, so we round that 4 up to a 5. So it's 19425 liters. Okay, next question. The fertilizer is made up of 3 ingredients, A, B, and C, in the following ratio. Work out the number of milliliters of B in 1 liter of fertilizer. Okay, so we've got A, we've got B, and we've got C, and they're in the ratio 1 is to 3 over 2 is to 5 over 3. Now we have two fractions here. What I'm going to do is simplify this. I'm going to change the ratio so that we have three whole numbers here instead of fractions. So what I'm going to do is multiply each number by 6. So if I multiply a by 6, I'll get 6. If I multiply 3 over 2, 3 over 2 times 6, you can do it on your calculator, but you'll get 3 6s 18 over 2, which is 9. So b then can be 9. And then c, I've got to multiply this by 6. So again, that's 5 over 3, multiplied by 6, I should say, over 1. 5 6 is 30, divided by 3, which is 10. So c can be 10 here. So this ratio here is exactly the same as this ratio here, but now I've just got whole numbers. So what you normally do with ratios is you would add up these three numbers here. So you do 6 plus 9 plus 10. That gives you 25. So what we need to do is look at b. So we need 9 of these 25ths of 1 litre. They're saying 1 litre. So it says milliliters here. We've got to give our answer in milliliters. You got to remember there are 1,000 milliliters in 1 litre. So I'm going to multiply this by 1,000. And what you get when you do that is 360 milliliters. So this is our answer here. Okay, next one. The tank for spreading fertilizer is in the shape of a cylinder. The radius of the tank is 90 centimeters and its length is 4 meters as shown in the diagram on the right. Work out the volume of the tank. Give your answer in cubic meters correct to 2 decimal places. Okay, so the volume of a cylinder is what we need, and that is pi r squared h. So all I've got to do is stick in the numbers. So pi we can use from our calculator. The radius is 90 centimeters. So 90 centimeters is equal to 0.9 meters. Remember, we need our answer in meters cubed, so I'm going to change this to meters. So I'm going to multiply by 0.9, which we got the square, and then the height is 4 meters. Okay, so you can just do that again on your calculator and you'll get 10.1787 and so on. So we need this correct to 2 decimal places, so I'm going to stop here. The number after the 7 is a 5, 6, 7, 8 or 9, so we'd have to take that 7 rounded up to an 8. So my answer for this question will be 10.18 and it's meters cubed. Okay, so this is the next part of the question. This diagram on the right shows a different cylindrical tank which has volume 81 pi over 125 cubic meters. Its length is 3 times as long as the radius is shown. Work out the radius of this tank in meters. Okay, so again we're looking at the volume of a cylinder, which is pi r squared h. Whenever there's a formula in these type of questions, always write it down. And you'll get these formulae in your tables. We know the volume of the cylinder. It is 81 pi over 125, and that's equal to pi times the radius, which we've got to work out and square here, and then the height. We don't want a second variable in here that we don't know, but we're told that the length is, or the height if you like, or the length is 3 times as long as the radius. So in other words, that's 3r, 3 times the radius. Okay, so all we've got to do is work out what r is here. We have an equation. The only unknown here is r, so we can isolate r. Now I see I've got a pi on the left hand side that's multiplied. I have a pi on the right hand side that's multiplied. So that works out nice and neatly. So on the left hand side we have 81 over 125. On the right hand side we've got r squared times 3 times r. So that's 3r cubed. Okay, so next thing I'm going to do is just divide both sides by 3. So when you divide the left hand side by 3, you get 27 over 125. On the right hand side, the 3 disappears and you get r cubed. So the next thing you've got to do here really is just cube root both sides. So in other words, you're going to do this. You're going to cube root that side, cube root that side. The reason you do that is because the cube root will get rid of that 3 there. So if you cube root the left hand side, well, I'll write it down first anyway, 27 over 125. I'm going to cube root that, and this is my answer here. So we're required to give our answer, let's see, work out the radius of this tank in meters. So we just have to work it out. So it will work out nice and neatly, I think. Now the way you cube root a fraction is you'll cube root the top and cube root the bottom. If you cube root the top, you'll get 3. 3 times 3 times 3 will give you 27. If you cube root the bottom, you'll get 5. 5 times 5 times 5 will give you 125. So that's really my answer there, and I think that is in meters. Yep, that is in meters. And that's really it, or you can say 0.6 meters either. Okay, and that's it for this question.